Okay. Bring it on. Yeah. It's a tough job. Okay, well, without further ado, I'd like to introduce Gerrit Verschuur. He's a radio astronomer. He's the author of several books on astronomy and has thought deeply about discovery over the years. He's an inventor. This current time, he's an adjunct professor of physics at the University of Memphis. He's also in politics and many, many other things. He is currently working on some research which if it works out the way he hopes, is exciting enough. It may even change the way we conceptualize some things in space. So he's very, very active intellectually. He's thought a lot about discovery. So please welcome Gerrit Verschuur.
Well, thank you very much for inviting me. It's a pleasure to be here. And by way of introduction of myself, leadership and discovery, I've had the good fortune of having made a couple of pretty significant discoveries in my scientific career. Back in 1968, I was the first person to measure the interstellar magnetic field strength. And since then, and I measured it in 5 directions, and since then I think it's fair to say that nobody else has succeeded in measuring any in the interstellar space. There's some controversy about that, but that's my statement right now. I also discovered the coldest hydrogen clouds ever observed anywhere. And to this day, nobody has any idea why they exist. But that's not quite so well known. My third discovery is one I'm going to hint at, and if somebody wants to ask me about it at the end, it is a potentially paradigm-shifting discovery in 2 fields, and it is pretty overwhelming. The paper will be published in Astrophysical Journal in December, and I do have a paper that was just published this month in the IEEE Transactions on Plasma Science, which is the beginning of the introduction to that discovery. So with that said, when Galileo found the moons of Jupiter back in 1610, there was stunning proof that an object other than the Earth was at the center of motion in the universe, for that matter. This discovery directly invalidated some of the teachings of the Church, because the Earth was supposed to be the center of the universe. So that leadership was challenged here. The leadership of the Church in knowing what was going on in the universe was challenged directly by a discovery by a scientist. And the Church leaders were so certain that they were correct, they didn't have to look through Galileo's telescope to see the phases of Venus, for example, or the moons of Jupiter. They didn't need to because they knew that couldn't be so. But this discovery by Galileo propelled him into his own leadership role, because he had made a discovery that revolutionized astronomy and our worldview. Now, this confrontation with accepted dogma or doctrine is a stage I think all discoveries must pass through, at least when one considers the earliest questions raised by curious human minds. And as an illustration, let me outline how an ancient question about the nature of magnetism came to be answered thousands of years after it was first posed. In my references to my paper, I actually refer to my books, which have lots of references that pertain to this. And so if you do read my article, the references are all in the original books. When first asked, no one had any idea why a lodestone could attract other pieces of iron as if by magic. So the first answers were inventions. The gurus or the priest or whoever was asked this question came up with answers which they invented. They were basically superstitions and essentially nonsense. And for 2,000 years, nobody had any idea why lodestone did what it did, and they couldn't possibly have answered the question because we know today that it's a very scientific one. But the first person who did something about it in a significant manner was William Gilbert in 1600, when he cleared the decks of all this superstition and nonsense. And he sorted out what was clearly nonsense and what was demonstrable. And his big breakthrough was that the Earth itself is a lodestone. It essentially has the properties of a lodestone. And Gilbert was able to, he published his book, The De Magnete, which many historians of science regard as the first true scientific thesis or treatise. And Gilbert did not run afoul of the Church, because the Church had said nothing about lodestone in the Bible. I mean, essentially the Bible had nothing to say about lodestone. Well, today we understand well, this is important to the history of science. Gilbert said essentially that there was this force that acted over a distance, which we now call magnetism or magnetic fields. And this was very important because it set the scene for Newton. It turns out that in the 1600s, after Gilbert, magnetism was invoked to explain virtually everything, such as planets staying in their orbits about the sun. So that when Newton came along and he had to invoke another force acting over a distance, the concept was already fresh in everybody's mind, and it was readily accepted. Well, today we understand that magnetism is produced by electrons in motion, but it took several centuries after Gilbert for this beautiful concept to emerge. And it required, above all, that scientists bring two forces under their control in the laboratory, one being electricity and one magnetism. Until you could control magnetism and electricity in the lab, you couldn't really do experiments with it. And the big breakthrough, of course, came with Ørsted discovering that current, which is electrons, we now know are electrons flowing along a wire, could produce a magnetic force. The concept of field hadn't been suggested then. That was one aspect of it. And then Faraday showed that if you move a magnet past a wire, it produced an electric current. Now, this was a huge conceptual leap because they both involve motion, which means time, and Maxwell then quickly realized that in order to explain electricity and magnetism, you had to bring in the concept of velocity, and then of course he derived his laws of electromagnetic radiation, which involved the speed of light. So there was a huge breakthrough. Unfortunately, Maxwell was open-minded enough to accept or respect what Faraday had discovered in the laboratory. Now, this is not always the case with so-called leaders in science, because scientists suffer human frailties such as ego and pride. And what springs to mind for me is the discovery of interstellar matter, about which I wrote another book. And it took at least 100, 150 years before the concept that there was something between the stars took hold. And the agonies of Edward Barnard, who was from Nashville, Tennessee, well documented. And it is interesting that one of the undisputed leaders of astrophysics in the early part of the 20th century, Eddington, gave a remarkably error-filled Bakerian lecture to the Royal Society, in which he said that one should presuppose the existence of interstellar matter, ignoring completely all the agonies that all these other scientists had been through, because as yet there was no outright proof that it existed. But Eddington's comment, and this is the importance of leadership in science, was taken seriously, even though historically you will see that other people had talked about it, but they weren't leaders. And as until a leader gave the blessing, the rest of the community didn't follow. But one of the people who did follow Eddington was Jan Oort, the Dutch astronomer who himself became a leader in astronomy. And he studied interstellar matter. And Oort's power over the Dutch astronomical community was pretty awesome. And I will give you one little anecdote that involved me, because I saw this embarrassingly revealed at an International Astronomical Union meeting, in which it was shortly after I had published a paper showing that the Milky Way galaxy may be bent in its outer regions. And the hydrogen gas, which I was studying in between the stars, in the outer regions of the galaxy, according to Oort, was close to the sun. And I said, no, this stuff is part of the bending of the galactic plane, this particular class of hydrogen. Well, one of the students of Oort, getting his PhD, had looked at another galaxy edge on and found exactly the same bending. And this was a major talk at an IAU meeting, and the student did not mention my result. Of course, being, we like to hear our results, at least other people talk about them. So I asked him afterwards, and he said, yes, I'm afraid I couldn't mention your results because Oort was sitting in the front row. Now, this is one of these insidious things, that the leader in the field dominates that field, and to challenge that leader is to risk your career, especially if you're a new student who hasn't quite got his PhD yet. And the funny thing about this particular student was that every time I've seen him since, he apologizes again. for not doing that. He still feels bad about it. So I'm cynical enough to believe that what I call journeyman researchers readily turn to leaders for validation of their work. Well, this has negative consequences because such researchers will not risk their careers in pursuing new ideas that are outside the current paradigm, which by definition is the one adhered to by the leader. So research becomes embroiled in politics. And that's when things can become quite nasty. One's grants and tenure application depend on peer recognition, which in turn depends on adhering to the status quo, which means thinking like the leader. You may gather by now that I tend not to think like the leaders in my field. Well, this raises uncomfortable questions about the perpetuation of the standard paradigm in various branches of science. One can argue that as a result, risk-taking has become devalued in favor of security and grant approval. I find myself outside this process because I, quote, dropped out several years ago, and I'm now doing research as a, quote, independent scholar without any grants. But I'll say maybe right at the end, if somebody wants to know about my new discovery, how it's possible for me to actually make a new discovery without grants. So what happens when someone does make a discovery that flies in the face of what the high priests accept to be true? It becomes really complex because that discovery may in fact invalidate a lifetime of work for somebody else, for a leader and his entourage. And in some case, the leader may have been hoping for some plaudits, a Nobel Prize or whatever, and then if somebody comes along and says, wait a minute, you overlooked this particular point, it becomes a threat to survival. So it is human nature to not allow the possibility that some young Turk, as we used to call the younger guys who were making new discoveries, could discover something in your field of research that sends it in a new direction and leaves you stranded. So it's also interesting that in the communication of science, and I've written many popular science books, and if you see, say, Science News or New Scientist reporting on a new discovery, almost every article will always go to, quote, a leader or some expert in the field to ask their opinion. And usually that expert will say something like, well, that's an interesting discovery, but we're going to have to get more data, and it flies in the face of what we already know, and that's the end of that particular report. So this brings me to the manner in which we do make discoveries, and something that I observed based on my experience, obviously, because I observed it, that the phases that a student might go through in dealing with discovery. For example, if a new student comes in and starts working on a project which research has been done for, say, 10 years already, at least, and the student doesn't know anything, but if the student's any good, at some point that student will ask a question and say, or come up with a bright idea, and come to the thesis advisor and say, oh, I've got this wonderful idea, and the thesis advisor will say, yes, that's very well, but that was discovered 8 years ago, and if you go and read it, you'll find that that's been done. And if the student doesn't get discouraged, they will have another idea, and they'll be told that, yes, that was done a couple of years ago, and slowly the student will catch up, and then someday the student will get an original idea and talk to the thesis advisor and realize that he or she is now at the forefront. And if they make a breakthrough at that point, it can become published, hopefully. So the process of then making further progress is the risky one, because if you now make a new discovery which nobody else knows about, there's a whole new set of issues that you have to deal with. First of all, the referees of your paper, who may not agree, and then that becomes a whole battle in itself in terms of how you deal with discovery. If your discovery happens to threaten a paradigm, then the problem of publishing it is really difficult. And it brings to mind Thomas Kuhn's hypothesis concerning paradigm shifts, that the depressing aspect is that the old paradigm tends to fall away only when the previous leaders die. So, if you do have that unfortunate experience, you may have to wait until you're dead to enjoy the fruits of your success. There are, of course, some classic examples of that in science. I think Alfred Wegener is one of my favorite examples of having the idea of continental drift and nobody accepting what he had discovered until he was essentially dead. So my advice to the young students is, be careful what you wish for. You might actually find something new. And at that point, the process becomes quite difficult. The other thing you've got to be careful of, you mustn't leap too far into the unknown, because then what you have to say becomes indistinguishable from the ravings of a lunatic as far as your colleagues are concerned. And I've seen people speak at AAS meetings even who could be put into that category. So you have to be, progress comes a step at a time, but those steps cannot be too big. If they are big, you'd better figure out how to make a few smaller ones to get to where you are so that others can understand what it is you've just discovered. Which, Tom mentioned that I've been a student of the discovery because I've written a chapter in one of my books and also a talk I gave to teachers that why do we scientists indulge ourselves in doing science? And I ask students this, and I say, why do you think we do science? And they all make, highfalutin comments like, oh, it's to understand the mysteries of the universe, and blah, blah, blah. And I say, no, my research has shown that we do it because we enjoy the thrill of discovery. It's what Maslow called the peak experience. And I interviewed a lot of my colleagues at the National Radio Astronomy Observatory at one point, and I said, why are you doing research? And they all confessed in some detail, and quite a few of them said, don't tell anybody this, that they had an experience where they discovered something new, and it was so exciting that they got this incredible high. And they would say to me, it's better than drugs or sex, but don't tell anybody. Or, it's better than sex for those who had never done drugs. So, in my particular case, when I measured the magnetic field for the first time, it was after 8 years of research, on and off, doing experiments with the big radio telescopes. And the day I saw that, it was an incredible high. And I only saw it 2 months after I got off the telescope. And a few months later, I did the experiment again, and I was able to see the signal at the telescope, and that was the highest experience of my life. And one of my colleagues pointed out, he said, I had that this high of discovery, and I know I'll never have it again, but I'm going to continue doing just in case I do. So it's an addictive experience. So my particular slant on this is that the thrill of discovery, finding out something new for yourself, is an addictive experience, and you like doing research because it feels good. I've gone to history of science meetings and listened to historians talk about, with due respect to the historians here, talking about they didn't understand why, what's his name, Hertz was doing what he was doing. And I know Hertz was doing what he was doing because it was exciting and he enjoyed it. But they were trying to come up with some abstract philosophical explanation. But Hertz was onto something exciting and new. And he was doing it because it was fun. Anyway, so let's digress here from my main theme. Let's see here. So what actually drives us to do this in the first place? And I like thinking about curiosity. I think curiosity obviously is the driving force behind our research endeavors. And that curiosity itself is a basic instinct which lies at the heart of our evolutionary success. Now, every species, I believe, is as curious as they need to be that particular type of species. And there's evidence. I've read biologist books about curiosity in very lowly creatures. Now, for us, this instinct comes with us at birth. And as you know, those who have kids, that there's a phase they go through where they keep asking why. And if you're lucky, and I think most scientists were lucky that the parents didn't beat it out of you, that you must stop asking why. And I think scientists continue through their whole life asking why. I actually asked a class in Maryland of 200 students once, confronted them head on, and I said, what would stop you from asking questions? Because I used to give them projects where they would have to write about their favorite topic in the context of astronomy, but they have to answer a question. And a lot of them confessed openly, like in a giant therapy session, that they had been beaten for asking questions, literally, and that they were afraid to, and some of them admitted that their parents were extremely religious, and they weren't allowed to ask questions. And I encouraged them to do that, and I had some wonderful success with students discovering things for themselves because I let them ask why and said, go and find the answer. So a lot of the classic questions which young kids will ask are very embarrassing to the authoritarian parent, like, why did that tornado kill all those people? And it's very hard to come up with an answer. But if you're religious, you just say, well, it's God's will. And that a lot of people don't accept that. One of my earliest experiences of asking why was there thunder and lightning when I was a kid. And I used to be terrified of those. And we lived next to a small lake, and across the other side of the railroad track, which crossed the small lake, was a big lake. And my father told me that there was a man flashing a searchlight up into the clouds on the big lake. And that the thunder was somebody unloading a load of drums, empty oil drums, to make the thunder noise. Well, a few years later, when I managed to paddle my leaky canoe to the big lake, I couldn't find the searchlight or piles of drums, so I knew that was nonsense. And it took me until the university years that I started learning something about thunder and lightning in detail. In terms of answering a question as a research scientist, it helps to indulge in a bit of a ritual. I've learned through experimentation on self-awareness that if you ask a question in a formal manner, you have a better chance of finding an answer, either by asking the question in writing, which was my way of doing it, and then experiencing the role of the unconscious or whatever in helping you find the answer. I have a whole manuscript on this. It's unpublished. It was my experiments with an isolation tank where I did experiments involving this. And I realized that prayer is just another form of seeking answers in a ritualistic manner. And our papers in science are also formulated in a ritualistic manner. You pose the question, what is it you want to find out? Of course, you paint a simple picture when you write your paper, but usually that process can be pretty arduous. But there's a well-known phenomenon known as synchronicity or coincidence, where if you do ask a question and seek answers, and many scientists have written about this in private, and some of them have published them, including Pauli and Jung in a famous book on synchronicity, you will get the answer coming to you, as if out of the blue, giving you the answers that you need. And you say, wow, that's a remarkable coincidence, but of course it's only a coincidence for you, because you were looking for the answer. So discovery involves a certain, it does require that you take that first step of asking why, and very specifically, if you want to phrase your question even more detailed, you will start having experiences which will give you the answers. So to get back to curiosity, I've argued that curiosity is essential for survival, and the more we know about our world, our environment, the better likely we are able to survive. Then the unexpected will not strike us down. And I think that the entire scientific endeavor, viewed from this particular point of view, is one in which we try to understand as to the maximum degree possible what's going on around us. Now, in individual little scientific projects, you may not see that connection, but if you look in the big picture, for example, discovering asteroids, near-Earth asteroids, which are capable of slamming into the planet, that's an extremely pro-survival thing to discover. And in many cases, what you discover may not please you. For example, it's not very pleasing to discover that we may get wiped out by an asteroid or a comet collision. But at least we've discovered that, and we can take steps, and Rusty Schweikert is one of the prime drivers in this, to an ex-astronaut to take steps to avoid being smashed by an asteroid or comet unexpectedly. So, and other things we don't want to discover, don't want to know about, and I live near in the Memphis area, and there, of course, this is a particularly hot topic still, that Darwin discovered that there was this phenomenon which is labeled evolution, and that's not very nice for people who have strong beliefs about the biblical origin of life. So that's not something a lot of people wanted anybody to discover. And at one point, my wife, who also teaches physics, and astronomy, went through a phase where if she even mentioned the word evolution throughout her, any time during her class, she was marked down by the students in the evaluations, and told so by the students. And she stopped mentioning it, then I pointed out that she was being part of the problem if she didn't. And now she doesn't mind. She's decided she's got to fight this as well. So we're engaged in the quest to uncover and understand the laws of the universe that govern our existence here. Which brings me back to the point I made originally, that the first answers to our questions in any realm of science that, as far as I can see, especially the ancient ones, like what is lightning, what is thunder, what is light, what are the wind, causes the wind, they were all answered in terms of gods and mysterious things, magnetism, electricity. But As we evolve our ability to deal with this, we learn through this incredible phenomenon called science to answer these questions, which used to be answered by the shamans and the gurus and the witch doctors and the priests. And of course the latter still hold much of the world's population hostage to their dogma. And if I look into the future, I can see that at some point we're going to have a massive, maybe we already started this upheaval where it's recognized by a lot of people who do adhere to strong religious beliefs that science is a danger, that discovery can reveal danger, can be dangerous to your beliefs. And we can't just remove those beliefs and expect people to live happily ever after. So my fear is that, and again, maybe it's because I'm biased living in the Memphis area, that we may be approaching another era when I especially look at the Bush administration and its treatment of some scientific facts, that we may be headed for another dark age, which is okay because it just means that the human beings will just go into that and come out the other end probably, hopefully. Still asking questions. So in seeking answers to the questions of the nature of life, I think we're still in the midst of an upheaval that may dwarf Galileo's struggle with the church, or even Darwin's for that matter. I'm acutely aware, again living in the Memphis area, of the lack of knowledge about what scientists have discovered on the part of the lay person. I think if the lay individual was to understand just how much scientists have learned, they would freak out. When you're just looking at medical stuff, biological, genetic, astronomical, physics, it's amazing what we've learned, and the majority of people have no idea what we're doing. So Galileo turned the world of astronomy upside down, and Darwin did the same for biology by making discoveries that brought a new, all-encompassing view to our place in space and life on Earth. Since then, we've been swept along by this tsunami of discoveries, and we've further refined our view of ourselves in this enormous universe. So to help us grasp what it all means, scientists turn to leaders in the field to help interpret the truths of their discoveries. Those leaders in turn will be overthrown as new data emerge, and which will force us to change our theories and paradigms as we come to terms with the new discoveries. This gloriously egalitarian endeavor we call science, or at least it should be egalitarian, is being played out on a world stage littered with the debris of ancient beliefs that threaten to overwhelm us. We operate in an intellectual environment that is grandly lacking in an appreciation of how far scientists have come, and which, in the USA at least, is, at least under the present administration, would bend the results of our discoveries to the whims of the politicians. So as scientists make even more discoveries related to our survival, we do so in the context of a huge disparity between the leaders who cater to the mental well-being of believers everywhere, leaders who have absolutely no idea what is going on in our laboratories and observatories, and in the field as we dig through the ruins and strata and assemble the jigsaw puzzle of the universe. Now this, I think we can be sure, further discoveries are not going to please everyone. Instead, I fear that the new leaders may emerge on the political front to silence the questioning and plunge us into another dark age, as I just said, after which our species might emerge renewed, or it might not. Such is life. Thank you. Yes.
I certainly accept what you say. Science is filled with the history of new paradigm-breaking ideas which have run smack into a brick wall of the establishment.
Right.
But there have been many paradigm-shifting ideas which have been accepted. Maybe the most recent of which in astronomy is the discovery that the universal expansion seems to be accelerating, which is totally unexpected, and may lead us to some fundamental new physics at some point. And yet everybody, it was totally unexpected, but it's been accepted. We don't understand it.
Right.
So I think somehow we've got to go deeper than, I mean, it's not as simple. Sometimes ideas are accepted, and sometimes they bounce off the wall of the establishment. And so somehow we have to look a little deeper than just that something is totally new and you have to wait for the old generation to die out.
The example you gave, I think, is sort of a void there into which that discovery could slip without shooting down anything in particular. It just said, we didn't think of this aspect, but there are others where you do run into the brick wall of accepted beliefs, which relates to my new discovery.
And the other thing I wanted, I mean, how can we not respond to your
Yes.
suggestion that you might have a paradigm shift?
Yes, I do have.
Here, which I'd love to hear about.
I'll try and say it in a few words. The universe, according to astronomers, began with the Big Bang. Fine, there's a cosmic microwave background. And recently spacecraft were launched to study details in that background, because if the universe has indeed begun with the Big Bang, then something had to happen at some point in the evolution of the universe that created galaxies. So you have patchiness, and the COBE spacecraft, and more recently the WMAP spacecraft, mapped the small-scale structure in detail. And the WMAP spacecraft people went to great lengths to subtract out all possible foreground sources of radiation. That's the one fact. The other fact is me sitting in Lakeland with the All-Sky Hydrogen Survey, which was done in Holland, and I've got this all-sky data on my computer. And most young astronomers have stampeded to the edge of the universe to do cosmology, and nobody's really looking at these data. But through a series of accidental visual observations of the relationship between hydrogen data and WMAP data, I looked closely, and I found that the WMAP structure correlates to an extraordinary degree with neutral hydrogen structure. And that was never looked at by the WMAP people. And the first reaction of the WMAP people has been those who are really into cosmology are saying, well, you're going to prove statistically. But it turns out to be very difficult. And my counter to that is, I have discovered several new things about interstellar matter by treating your signal as simply a signal in that direction of the sky. And when I look at the hydrogen, they all fit together. There's morphologically identical structures, slightly offset, sometimes aligned. And in one case, I can see X-rays, H-alpha, hydrogen, and WMAP, all associated. And this paper, the first paper is appearing in December. And that is not good news for the people who are at the edge of the universe. So when I give a seminar on this subject, I end up by inviting some of the young cosmologists to come back to the galaxy, because we've completely overlooked the fact that we don't understand diffuse interstellar matter. It's complex plasma phenomena occurring, hydrogen clouds collide, where they heat up at the interface, you get weak continuum of emission, and that's what WMAP is seeing, I think. So I've got a reprint here from the Transactions of Plasma Science, one copy if anybody wants it. This was published in August. Yeah.
I share your views about the Bush administration and science with respect to the issue of stem cell research, but I also think that the stem cell research is just the first step. There's so much going on in biological sciences, advancing human cloning,
Yes.
mating of genes from animals to humans. And there's got to be, it seems to me, at some point, either the scientific community will start policing itself, or the politicians are going to start setting rules about what is taboo and what is
Yeah.
to be done in research. So this question of leadership, so when a field is like life science, which is filled with emotion and religion and everything else, if you don't want the government to regulate, you're going to have to come up with some kind of barrier or buffer between the government and the scientific community. It's just obvious.
Yeah. And I don't see a way out. I don't see it happening.
Is anybody talking about this?
No. I've just started publicly talking about this.
But if Gerrit's notion of why we do research, just curiosity, is correct, which I think it is, then I don't know how you can possibly draw a line anywhere. I mean, the government, because presumably it's not staffed by people interested in research, it's staffed by people who want to get reelected, may feel comfortable drawing that line. But I can't imagine any research community respecting it.
Well, but you've got two communities that are totally different, but you've got issues coming up.
It's a big subject you would just raise here.
I mean, you may be curious about how a human being will react if you torture them or put them in cold water, but we don't do that, and we police ourselves.
Yes.
So I think there's that piece, and I do think, I agree with you, I think at least in my own personal intuition is that some of my best science has been purely curiosity driven.
Purely what?
Curiosity
Oh, yes.
driven. And when I look for new graduate students, I look to see, are they even curious about, why is the hallway shaped this way? Why is your office located here and not, on the wing where
Yes.
the other faculty offices are located?
Yes.
Why, I look for those sparks because I think that's the only thing that does keep you working those 10 hours or,
Yes.
as Karen mentioned, that's what gets you up at 3 a.m. Or in my case, that's what keeps me up
Right.
until 7 a.m. on some nights. But having said that, to kind of wrap back up, I think that there is that curiosity driven, but I think the piece, and as I talked about in my presentation, where the rubber meets the road is where it goes beyond science to proprietary type things or policy type things. And I think there are, and I'm getting more jaded in believing that there are scientists who perhaps in another era of their life or perhaps their colleagues are motivated just by the quest of knowledge, but there's others who are really motivated by financial gains, by fame, by whatever. And in that way, it almost becomes a business of science. And that's what I think is going to bring in the regulation more so than anything. For example, on the cloning, I think we all kind of wonder and think, and clearly there would be sociological influence, but it's I'm going to go out and sell this mechanism to allow everyone else to do it, or I'm going to market this genetic test. And you guys probably saw I was in the New York Times last week with, and I'm block on his name, the over 50 syndrome, who has now sequenced he published in PLO biology, right, Brendan, his sequence, and the next line was, and soon we hope to have these kits so that everybody else can do that. So it was taking it from scientific discovery to marketing.
Into engineering.
3 paragraphs of the New York Times.
Yeah.
And I think that's where we are going to cause ourselves to be shepherded by government or anyone else because we're going to become a business more so than just a scientific enterprise.
Yes.
Yeah, I was struck by Morton and Karen's and your talks in terms of the role of leaders in science and the fact that in the beginning of your talk, when you talked about the graduate student, I was thinking about the Greeks were very careful to distinguish between a ruler and a tyrant.
Mm-hmm.
And it struck me that you were describing the tyrant leader in science, or at least the perception of the leader as a tyrant. Whereas in Karen's talk, when you looked at the 3 levels of leaders, I think you were assuming the angel side a little bit more. And it's interesting to look at that juxtaposition. And then in Morton's talk, what I thought was interesting was that we had some interesting questions about whether or not people were living up to their obligations to tell the truth, who were leaders in the fields. And they were leaders who were silent leaders. So I think between the 3, you've got these 3 models of leadership. And the interesting question in the sciences is one model of leadership, it requires a kind of tolerance for, because you talk about overthrowing, you really only need to overthrow tyrants. You don't need to overthrow good leaders in science. The leader would look at that
Right.
young graduate student.
But then all these tyrants are called referees, according to most of us.
Right, yes. Well, and it does speak to, I think, the fact that one thing that has struck me over the years is I do a lot of work with businesses sometimes, and how bad academic leadership is down the line in all sorts of ways, and yet we think we're far superior in all sorts of
Right.
ways to those nasty business people who actually probably have, there are tyrannical leaders, but when it comes to good ideas in business, good ideas are usually welcomed and embraced.
Yeah, make money.
Right.
I'm struck by, in this class that you set up, I wonder how much the apostles of reason, the scientists anyway, are the people who are the real leaders, or are the real leaders in your scenario going to be the people who are going to necessarily mediate much of the fallout that's brought about by discovery? That all kinds of discovery we're talking about, be it scientific or be it in terms of exploration, is always involves a process of dealing with that shock of discovery, using old traditions to make sense of that shock of discovery, and then using that process itself to continue new discovery. And a leader, to a certain extent, is somebody who's going to master that whole process, as opposed to someone who is, you know, the scientist making the big breakthrough, or the explorer on the ship. So in terms, the Henry the Navigator and the people who are going to enable these kinds of things, as they're trying to kind of make sense of what these literally and figurative new worlds mean, they're the ones who are kind of the leaders in this process.
Interesting point, yes.
Yeah, not so much a question but a comment, but just a task that a leader has, probably in all endeavors, but especially for the endeavor of discovery that I don't think we've approached yet, which is raising the next generation of leaders. And I think some of your comments bring up some interesting points in the sense that sometimes there are fields that have leaders that are not congenial to anything that doesn't toe the line for the next generation. And within psychology, I wouldn't say that I've seen that, but I've seen a softer version of that, where there are some theoretical breakthroughs and absolutely worthy, who draw accolades to the next generation, who then hold to those breakthroughs and overgeneralize those breakthroughs simply because that's the fashion in some respects. And so, what that's meant is I've seen some sub-areas of psychology, I don't know if you tend to have the same observation or not.
Mirror neurons is a great example.
What?
And mirror neurons is a great example.
Yeah.
And it is a great example. In fact, I almost was going to work that in to my talk as a parallel to the autism epidemic, which is the phenomenon. People I think have heard about mirror neurons. Supposedly they're these neurons that fire when you observe someone doing something, just as they fire when you do it. The reality is they have never been documented in humans. Never. And there are over 300 papers in the scientific literature which falsely cite 4 original papers as the documentation. And those 4 papers even say that they don't document it. So it's become this huge myth of the mirror neuron. And I think it's another example.
And it isn't the only example, but the net effect of what it does is sort of knowledge gets frozen for a generation because people
just keep churning this out and falsely citing these
That's
articles.
right. So they'll either believe or that a field that looks very promising will sometimes diminish in the second generation of scholars because the second generation of scholars are just sort of filtering out the details of what the first generation found out without trying to challenge or without trying to sort of think outside the theme or the fashions of the first generation as articulated. And that's often something I've wondered about in terms of leadership, a task that at least in terms of discovery, I'm sort of surprised there isn't more thought of, there isn't more discussion of, there isn't more scholarship of, simply because I've seen a lot of terrific stuff turned out.
The training of questioning authority, is that what you're trying to say?
No, you just don't have to do, you either don't have to do this phenomenon to death, or the field closest to my field is, and my talk is very representative of this, is I come from a tradition that, lays out the foibles, tells everybody how horrible things are in terms of human judgment. But, and sometimes I'll get papers to review where what we'll get is that people are getting it 99 or 98% right, but the researchers are focusing on the 2% that are wrong. And as a reviewer, I kind of say, well, you sort of missed the message here. People are really getting this thing right, and isn't that a surprise? But it doesn't follow the fashion, the form, or the template for research in that
Well, it's
field.
unsurprising, because, particularly if everyone is, like your research suggests, if everyone's expecting that we're right, and that's not the news. That's not the man bites dogs.
That's true, but in the field, at least the field that I'm in, when people get it right, it's news.
Yeah.
But you will find that young researchers don't recognize that because they sort of shrunk themselves into the analysis that their elders did. And as a consequence, they sort of miss things that are in the data or miss new phenomena simply because they aren't allowing themselves freedom of exploration. They're asking themselves new questions. They don't have to be challenging questions, but new questions that their elders would not have asked.
Yeah, I'd like to say one more thing about discovery and teaching. In the experience I have with my classes for many years, that they had to write an essay on answering a question. That learning something for yourself is the most powerful way of learning anything, as you know. And my most successful story was a student from Finland, and she was in her 4th year at University of Maryland, but she had to do an astronomy class to get her degree. And she timidly asked me, could she answer the question, what are aurorae? And she'd grown up in Finland and seen the aurora and had never been told in class And I never asked, what is an aurora? So when she did it in the class, I said, sure, do it. And then she got up, after it was all done, she got up in front of the 250 students and said this was the most exciting thing she had ever done at the university in 4 years. She found out what caused the aurora. And that was just, I mean, that's going to stay with her for the rest of her life. And it stayed with me for the rest of my life too, because it was such a rewarding experience. And discovery as a method to teach is also very important.
That's a good place to end, I think, on our, oh, do you have one more here?
Well, may I? I mean,
Yeah.
you know, people have had enough. I mean, I just want to revert to a paradigm that Ron offers, you know, his simplicity when he was talking about realistic fiction. And, you know, if we were all characters in a novel, a reader would be very mistrustful of your professed motive for what you do, and would say, I detect in the language of this character another implied motive which he's not being frank about, which is that Verschuur is really a sort of nation. He's a kind of, he's got a vocation for subversion. And what really gives him his high, what really gives him his buzz, is not just the discovery, because of course, you know, I absolutely accept that you get that high when you make a discovery. What really gives you the buzz is challenging the orthodoxy.
He's a psychologist, after all.
Yeah, I was just saying.
And I,
Very astute.
well, I mean, I'm postulating here a reader of the work of fiction. I'm not by any means trying to accuse you of dishonesty, because I know that you know, that wouldn't just would be inconsistent with your character and your work. But it's a kind of way of looking at it, and it does make me wonder, you know, what such a reader would make of your insistence on the polarity of religion and science. You know, what is going on here? Because if you look candidly at what you've told us, the polarity isn't between religion and science. It's between disinterested pursuit of the truth on the one hand and a sort of hierophantic assertion of the perfection of existing doctrine on the other. And you gave us plenty of examples of scientists as well as priests and shamans and magicians defending, being hierophants and defending those dogmas. So, I mean, in my invitation to, as if you were a character in a work of fiction, would you at this point in the story maybe revise a little what you've said and withdraw a bit from the insistence that religion and science are in opposition here, and acknowledge that they can be in apposition and that the disinterested search for truth is something which religious people pursue and people with scientific proclivities pursue, and those people are often and generally in the course of history have been the same.
Well, that's a huge one, but I would say it's a lot of semantic. We could argue about that from a semantic point of view. I mean, I do have strong feelings about the difference between science and religion. I don't think there's much common ground. I don't, you know, different way of looking at the world, and maybe that's what you're saying too.
There is a difference between.
Religion is one of the sacred cows that resist research. One here in Virginia that sparked a firestorm a decade ago was the research into, was Thomas Jefferson fathering children by his slaves? No religion involved at all, but he is part of our part of the sacred sphere in Virginia. We just couldn't tolerate that.
If you use the words dogma, which you used, or fundamentalism, which I think is pretty widespread around where you live, rather than religion, there may not be this difference of
Because we
opinion.
have political dogma, we have social dogma, we have religious
Theology
dogma.
versus
Yeah.
I do hope